All right, so a log function is the inverse of an exponential function. We've already graphed exponentials, so we are going to graph logs now. This is going on page 74 when we're done. And so your log function is going to look like this. F of x equals log base b of x, whatever the base may be. Okay, so a log function is the inverse. Like I said, we've already done the exponential, so let's just talk about exponential. When I'm going to graph this, I have an asymptote. Where's my asymptote? 0. Okay, so it's here, right? And anytime you graph the parent function of an exponential, what is your y-intercept? The y-intercept. When x is 0, what's y going to be? 1. So it's always going to go through 1. So your parent function looks something like this. Okay? Right, with that being your y-intercept. So when you take the inverse, when you have the inverse functions, what happens? How do you do that algebraically? You flip the x and y. So x becomes y becomes x. So your asymptote for an exponential is y equals 0. So what do you think it's going to be for a log? Well, it is y equals 0 for an exponential. So it would be x equals 0. So it would look like this. This would be your asymptote for a log. You have this point, which is at 0, 1. So where do you think another key point is going to be here? 1, 0. Okay, so you have this 1, 0 point right here. And then your log looks like this. Okay, it is a reflection on the line y equals x. Okay, yes, and please use colors if that's helpful for you. We've got them there on your table. Okay, so it's just an inverse. So we're switching x and y. And knowing to switch x and y is important because that's what's going to help us graph these. Okay, you can graph them pretty easily. And it says to graph a logarithmic function, you can use the inverse exponential function, and then you invert the values. So we're going to kind of look at it that way. I think that's the easiest way to go about what we're going to do when we're graphing them. Okay, so let's look at one of these. This is a parent function because I don't have any transformations happening here. And this is a log function, so since there are no transformations happening, I know that my asymptote is here at x equals 0. So my asymptote is x equals 0. And then I'm going to rewrite this in exponential form. So I'm going to basically change that f of x to y so that I can figure out what's happening here. To rewrite a log in exponential form, the base here is 3. So this is 3 to the y equals x. Okay, so that's just rewriting the log in exponential form. Everybody with me? So we have 3 key anchor points for our parent function. This is just a parent function, so it is what it is here. And we are going to write those out. So here, the reason we want to rewrite it this way is we always choose numbers for x and then figure out what y is, but we're going to do it the opposite way. We've basically been doing this same kind of thing with parent functions. We just usually don't make a little t-chart because we just say, hey, when x is this, what is y, and we plot it. But because we're doing it opposite, it's really a good idea to jot it down so you don't get it backwards in your head, because it's easy to do, but it's also easy to get backwards. So instead of choosing numbers for x like we usually do, we're going to choose numbers for y, and you're always going to choose -1, 0, and 1 every time. Okay? And then your little t-chart will be super easy to come up with. Every single time it's going to be easy. So -1. When y is -1, what does that negative do to that 3? Okay. What? 1/3. It's called the what? What's reciprocal? So this when y is -1, x would have to be 1/3. When y is 0, what's x going to be? 1. And when y is 1, x is 3. So there are your 3 points. And these are my anchor points. They're also just my points because I don't actually translate it or transform anywhere. So then I go and plot this. When x is 1/3, y is -1. When x is 1, y is 0. When x is 3, y is 1. And then this is my function here. Okay. So what's my domain? Good. 0 to infinity. Do I include 0? No, I do not, because there's an asymptote there. What's my range? Negative infinity to positive infinity. So your range is going to be negative infinity to positive infinity on all of them. Even with any transformations, that is always going to be your range. Your domain can change, and it could change from your translations left and right. Okay, but range is always that. Then your x-intercept is an important point. This is at 1, 0. Is this an increasing or decreasing function? Increasing. And it's an all or nothing thing here. We've had some functions where it could be increasing on part of it and decreasing on part of it, but those don't work this way. So it's either all or nothing. So it is increasing, and that's going from 0 to infinity, and that means decreasing has to be none. Then my end behavior. As x approaches infinity, y approaches infinity. Now, and then I copied and pasted and I messed this up. And well, I copied and pasted it from the first time I messed up, telling myself I needed to fix it, and I still didn't fix it. So this should be negative infinity right there. So as x approaches negative infinity, which it really doesn't. This is one of those weird ones where we're actually really approaching 0, but we haven't talked about limits yet. So we're just going to think of it as when x gets as small as it possibly can, then y is approaching negative infinity. Okay. Okay, we good with that? Any questions? All right, so let's try this next one. We have this here. We're going to say that's equal to y. So the first thing we're going to do is rewrite it in exponential form. So 1/2 to the y power equals x. Then I make a little t-chart, and I choose -1, 0, and 1 for y. So when y is -1, what is x going to be? 2. When y is 0, get 1. And when it's 1, it is 1/2. Okay, so again, very easy to come up with. We just want to make sure and jot it down so we get it right when we graph it. So my asymptote, since there are no transformations, it is still here at x equals 0. So we say x equals 0 here. And then I'm going to graph this. So when x is 2, y is -1. When x is 1, y is 0. And when x is 1/2, y is 1. And it looks like this. So notice these two. I mean, the points are a little bit different because we're using 3 and 1/2, but it's a reflection in the x-axis. So this is what it looks like when your base is greater than 1. This is what it looks like when your base is between 0 and 1. Okay, everybody good? Easy enough? All right, and we're not going to worry about filling in the charts on every single one of them. We'll make it go a little bit faster. All right, so let's graph this next one. So now we have the natural log of x. All right, so we need to rewrite this in exponential form. What's the base? No, it's a natural log.
Oh, 2.7
E. So this is going to be e to the y equals x, right? So then I have my little t-chart here. The only reason you write down a decimal number here is because you're estimating here. You would never, ever put 2.7 to the y power. That doesn't make any sense at all. We just need to be able to estimate on here. And if you did ever use a decimal, it would be to 3 decimal places anyway. But I still am choosing -1, 0, and 1. So when y is -1, I actually get 1 over e. Does anybody remember what that decimal was close to? Okay, it was about 0.36. That's a number you kind of need to know. Okay, so 0.36, something. When y is 0, x is what? 1. And when y is 1, it's about 2.7 something, but that's good enough to estimate on these little graphs. Okay. So then I go and I plot my points. When x is about 0.36, so it's about 1/3 of the way, y is -1. When x is 1, y is 0. And when x is about 2.7, y is 1. I have an asymptote at x equals 0. And I draw my graph it. Looks something like that. Looks very much like your one where you had a base of 3, right? It shouldn't be that much. It's not going to be that much different. Okay. Everybody okay with all that? So now let's look at some with transformations. All right. So this first one here, even though we have a transformation, we are going to write down what our parent function is in exponential form. Not the whole thing in exponential form, just the parent function. So basically, I ignore any of the transformations going on. So the parent function would be 1/3 to the y power equals x. All right. Then I'm going to write down my little t table for my parent function. And that's going to be x and y. So I get -1, 0, and 1. So for my parent function, if y is -1, then x is 3, and then that would be 1 and 1/3. Okay? That's strictly the parent function. So then I need to talk about my transformations. Well, all that's happening here is this 1 is going to do what? Up 1. So it's going to be translate up 1. So the easiest way to do these is not to make a t-table and go and calculate all these values, because chances are pretty good. Sometimes you'll pick a number that's not going to work out too nicely for you, and then you're going to regret it, right? So we are going to use our parent function points and then do our transformations. It makes it that easy, right? What is the only type of transformation that's going to affect my asymptote? Left and right. Okay, so if I'm moving left and right, my asymptote goes with me. Otherwise, it stays the same. I'm not moving left or right, so my asymptote is right here at x equals 0 still. Okay. So then I look at my parent function points. So for my parent function, when x is 3, y is -1. Okay, that's my parent function point. You put your pencil right there. And then we just want to translate up 1, so I end up right there. Then when x is 1, y is 0, but I translate up 1. When x is 1/3, y is 1, but I translate up 1. Those are my 3 points. You should have at least 3 points, those 3 anchor points graphed every single time. Sometimes you'll have 4 if your x-intercept isn't included in there. Do I have an x-intercept? Yes, so I'm good. And then I just sketch in my graph. And it looks something like this. Okay, everybody okay with that? Yes. All right, so let's look at the next one. So I've got this. I'm going to, again, write my parent function in exponential form. My parent function would be 2 to the y power equals x. I jot down my t-table just so that I don't get my numbers backwards, because it's very simple, and I know that. That's not a bad thing. Like, you know, it's a good thing to sort of write it down. So -1, 0, and 1. So when y is -1, I get 1/2, and then 1, and then 2. Trust me, if the numbers are sitting there right in front of you, you are way less likely to go do something weird, because it's very easy to go do something weird. Okay, so then I write down my transformations. What does this negative do? Good. It's going to reflect in the x-axis, because if it was directly affecting x, then it would be in y. So this is not directly affecting x, so it is in the x-axis. And then this 2 does what? Good. It's going to translate right to. All right, so then when I go to graph it, and we're going to fill out the little chart for this one, and then we won't do it for any of the rest of them. But I'm going to translate to the right 2. So does that affect my asymptote? Yes. So instead of at x equals 0, it's going to be here at x equals 2. So our asymptote is at x equals 2. And then I'm going to go and plot my points. So I start here. When x is 1/2, y is at -1. So I'm right here for my parent function. I reflect in the x-axis. It ends up right there. And then I translate to the right 2. And my point ends up right there. Then I'm at 1, 0. I reflect in the x-axis, which means I don't go anywhere. And then I move to the right 2. When x is 2, y is 1. I reflect in the x-axis, move to the right 2. There are my 3 points. It does include my x-intercept, so I'm good. And I can sketch that in. Okay? Everybody okay with all that? So let's finish this up here. What's my domain? 2 to infinity. Good. Do I include 2? No. My range would be? Good. Negative infinity to infinity. X-intercept is at 3, 0. Am I increasing or decreasing? Decreasing. So this is a none. And I'm decreasing from 2 to infinity because it's always your x intervals. So then as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, or as it gets as small as it possibly can, it approaches infinity. Okay, everybody good with that? Easy enough? Awesome. All right, so we won't fill any more of those. Let's just graph the other ones. These are all good. I couldn't take any of them off because different things happen, so it's good to look at. All right, next piece of paper. So we get, write our parent function. We're going to go 4 to the y power equals x, right? Make my little t-chart. Need negative 1, 0, and 1. So that means when y is negative 1, this is 1/4. Then it would be 1 and 4. My transformations, well, I'm just translating here, right? I'm going to translate. What does the 5 do? Left 5 and down 2. All right, so does it affect my asymptote? Yes, I go to the left 5, so I'm going to go 1, 2, 3, 4, 5. So I'm going to be here at x equals negative 5. So that, look at my parent function points. When x is 1/4, y is negative 1. Then from there, I'm going to go to the left 5 and down 2. Bam, there we go. And then I'm going to go from 1, 0, and I go to the left 5 and down 2. And then I'm at 4, 1, so I go to the left 5 and down 2. What am I missing here? My x-intercept. So I find my x-intercept when what? When y equals 0. Okay, so I'm going to substitute 0 in for y. That's equal to log base 4 of x plus 5 minus 2. So I got to solve for x. So I'm going to add 2 to both sides. So we get 2 equals log base 4 of x plus 5. Can I rewrite this as an exponential? What's the base of my log here? 4. So just like I rewrote it here, I can make this 4 to the second power equals x plus 5. Does that make sense? Rewriting it as an exponential. So what's 4 squared? 16. So I get 16 equals x plus 5, which means x equals 11. Okay, so 11, 0 is my x-intercept. This only goes to 10, so we can make that like 11. But that helps me with my shape, so I don't pop up over the x-axis too soon there. And it's going to look something like that. Okay. Everybody good? So let's look at the next one. So we're going to get 1/2. So my parent function is 1/2 to the y power equals x. And if I have a fraction, I need to put it in parentheses. Otherwise, it looks like just the numerator goes to that exponent. So there's my x and my y. So negative 1, 0, and 1. So that'll give me 2, 1, and 1/2. So what does this negative here do? Reflects in the y-axis. Good. And then we translate up 3. So does that affect my asymptote? No. So my asymptote is still here at x equals 0. and then I start at 2, -1, right here. Then I'm going to reflect in the y-axis, which ends up over here, and then I translate up 3. I start at 1, 0, reflect in the y-axis, translate up 3. Then I'm going to start at 1/2, 1, reflect in the in the y-axis, and move up 1, 2, 3. So it looks like that. What am I missing? My x-intercept, okay? And does this one end up being weird? It doesn't end up being weird, really. So I'm going to get, let's see, 0 equals log base 1/2 of -x plus 3. So this is -3 equals log base 1/2 of -x. So I'm going to get -3 to the 1/2 power equals, I'm sorry, not -3 to the 1/2 power. What did I just do wrong? Is that right? No, shoot, I'm making stuff up. Y'all didn't stop me. I knew something was wrong. Okay. Now my base is 1/2, so it's 1/2 to the -3 power equals -x. All right, so what does the negative on this power do? Reciprocal. So it's really going to be 2 to the 3rd power. What's 2 to the 3rd power? 8. So this is 8 equals -x. So x equals -8. So that is my x-intercept right there. And then I can graph it just like this. So you need that x-intercept if you don't have it, because it helps you with that, with the shape there. Okay. Everybody good? So now we have a natural log, but remember we're going to write our parent function in exponential form. So what's the base when we have a natural log? E. So e to the y power equals x. So we come up with our little t-chart here, -1, 0, and 1. And so for x, this is going to be 1 over e. I'm sorry, when y is -1, e is going to be, or x is going to be 1 over e, which is about 0.36, right? 0 makes it 1. 1 makes it about 2.7. Then we look at our transformations. What does that 3 do? Stretch. Good. It is a vertical stretch by a factor of 3. And then that 1 is going to be a translation where? Down 1. So is my asymptote affected here? No, it is not. So it is still here at x equals 0. So then I have this, when x is about 0.36, y is at -1. So a vertical stretch of 3 means you take your y value and multiply it by 3. So that -1 becomes -3. Then I translate down 1, so I end up actually at -4. So then, when I'm at 1, x is 1, y is 0, vertical stretch of 3, well 0 times 3 is just 0, right? And then I translate down 1, end up right there. So then when x is about 2.7, y is 1, I have a vertical stretch of 3, so that becomes 3. Then I translate down 1, and I'm back down here at 2. All right, now I do not have the x value here, so I'm just going to tell you that when you do that, you get a e to the 1/3 power. Do you have any idea what e to the 1/3 power is? It's the cube root of e. You don't know what it is, it's fine. We don't, in that case, you would leave it. It's kind of like if you got the square root of 5. All right, it's the square root of 5. I can't go, pinpoint that on there. And that's fine. So we're just going to sketch in what we have. And it looks something like that. Okay. Any questions? So on the natural log ones, don't worry about it right now. We'll look at that later on how to do that. Okay? Yes? Right, so the natural log ones are the only ones that are going to come out weird where you can't plot them, so you can just ignore that for right now. Okay, we good? Any questions? Awesome. Go ahead and glue or tape these in right now, and I'll give you the assignment. You should be able to get them graphed and turned in before you leave.